This is Unit 9, Kinetics and Equilibrium. Lesson 4, Equilibrium. How do reactions behave once initiated? The objectives of this lesson: I can determine if a reaction is spontaneous, and I can determine if the entropy increases or decreases in a reaction. So do now. Equilibrium is defined as the rate of the forward reaction is defined when the rate of the forward reaction is equal to the rate of the reverse reaction. Equilibrium is dynamic, which means it's in constant motion. So we've heard that phrase before from living environment, and I've mentioned it before. Equilibrium is represented by a double-headed arrow. So this double-headed arrow shows that this reaction is in equilibrium. So we basically are having an equal amount of an equal rate. The rate of the forward reaction is equal to the rate of that reverse reaction. So there are different types of equilibrium, and these all occur in a closed system. So that's our caveat for this. We have a physical or a phase equilibrium, and this is where the rate of the forward phase change equals the rate of the reverse phase change. For example, the rate of vaporizing is equal to the rate of condensing. Therefore, I have an equilibrium between our solid, our liquid, and our gas. This means the water is vaporizing at the same rate it is condensing. So that would be what would happen inside a closed container of liquid. And we demonstrate this by a liquid to a gas is the easiest to visualize and represent. When the water vapor evaporates at the same rate it condenses in a closed container, we have a dynamic equilibrium existing. So to begin with, we have all evaporation. However, once we have reached our vapor pressure, we filled this with as much gas as possible. We will now have an equal rate where the gas and the liquid are vaporizing and condensing um, dynamically. The second type of equilibrium is the chemical equilibrium, where the rate of the forward reaction is equal to the rate of the reverse reaction. For example, the Haber process, where I take nitrogen and hydrogen and produce ammonium. This was a very important process, and this is a very important process in producing fertilizer. And this was one of the ways that we were able to increase our food production across the world. You demonstrated this doing that lab with the colored solutions, where we saw the volume in beaker A reduce and the volume in beaker B increase until they reached an equilibrium where the rates of the back and forth were the same, even though the amounts within them were not the same. A solution equilibrium exists when the rate of dissolving is equal to the rate of precipitating. So if I have a solution, if I have some solid sodium chloride in water and I produce aqueous ions, I will have an equilibrium between the solid and those ions. And I can show that with this picture here, where I have my solids at the bottom. So the amount of solid dissolving is not the amount, the rate of the solid dissolving is equal to the rate of this solution precipitating. So will a reaction happen on its own, which is what we call spontaneous, once it is started? Spontaneous reactions are defined as a reaction that happens on its own once initiated. Exothermic reactions are spontaneous because they have lower activation energy. Reactions that have an increase in entropy will also be considered spontaneous. So stop and think, which reaction will occur spontaneously? And according to table I, which reaction will occur spontaneously? Recall the definition of entropy. It's defined as the randomness or disorder of the system. The more substances that there are, the more entropy. In addition, the higher the temperature, the more entropy. So those are different ways that we can think about how entropy changes. And here's a visual representation. So entropy in the states of matter. This is an important diagram that you don't necessarily have to draw every picture, but know that solids have less entropy than liquids, which have less entropy than aqueous solutions, which have less entropy than gases. An analogy is you like to have low enthalpy or low energy when it comes to your chores, don't we all? As a result, your room tends to have very high entropy. It's very messy, it's very disordered. This is what nature prefers: low enthalpy and high entropy. So, for example, determine if there's an increase or decrease in entropy. So, some of our different ways that we increase entropy if there are more things or if we have gases. So, in our first example, I'm starting with a solid and I'm ending with a solid and gas. So, I have more products, and including a gas. So, this means I have an increase. If I'm going from a liquid to a solid, recall our different phases. Solids have less entropy, therefore, I'm decreasing my entropy. If I'm going from a solid to a gas, recall gases have the highest amount of entropy, so the change here is an increase in entropy. So check your understanding. You can look on your notes for that last question and 4 and 5. So you can determine if a reaction is spontaneous, and you can determine if entropy increases or decreases in a reaction.